is recording. Okay, so we're doing 8.1, similar polygons. It's right after dilations. Remember, feel free to ask questions. Just raise your hand or unmute yourself. So we're going to start with the lesson objective. And really, all I want you to do, students will be able to use similarity transformations, which means dilations, to find corresponding parts. In similar figures. So now we're actually just going to be finding numbers. If you do want to follow along in your book, it is on page 418. Okay? So recall from chapter 4 that two geometric figures are similar if and only if there is a similarity transformation that maps one figure onto the other. So we're still going to do scale factor k. It's either going to enlarge or reduce. Let's just remember what k is. K is the ratio of the image divided by the pre-image. Okay, so with that definition, if k is greater than 1, remember greater than 100%, then that's going to be an enlargement. And if k is a fraction that's less than 1, that's going to be a reduction. So remember, a similarity transformation changes the size, not the shape. Okay. And this is how it's presented to us, corresponding parts of similar polygons. So I have just two triangles. This could be any shape. But they have to be in the same position to see which ones are the corresponding parts. So this big black arrow represents a similarity transformation. With scale factor k. And if I have this smaller one, I'll go ahead and label it. I have A, B, and C. So our angles are A, B, and C, but the sides across from them we'll call small a. This will be small b. This will be small c. And if I take this figure and I map it onto this figure, well, I'm going to have a different shape. It's the same shape, different size. Clearly that's bigger. Angle A will be correspondent to angle D, so those are the same size. Angle B will be the same size as angle E, and C will be the same size as C. Now, instead of putting a little f over here, what I'm going to do is just put k times c, because that's going to be that much bigger. This one here is going to be k times a, because that corresponds to this, and you can probably tell this one down here is going to be kb. So that's how it corresponds. It also preserves angle measure, so we can write that angle A is congruent to angle D. Angle B is congruent to angle E. And angle C is congruent to angle F. The scale factor k that enlarges or reduces keeps the corresponding side lengths proportional. And that also, another way to say that is in proportion. So that means we can write proportional relationships. Remember, k is a proportion, which means we can do the corresponding sides here. And I'm going to actually use my colors because I think this looks so much better. So what I can do is I can write this one, EF, that image, and that corresponds to BC. you can also write, let's do the bottom one, DF is going to correspond to AC. And that's a proportion. When you write a fraction equal to a fraction, that's a proportion. But wait, there's more. This one here that I'm now doing in green is also in proportion. And so it's DF. No, that's an E. DE corresponds to AB. And all three of those ratios are equal to our number K. And that's going to help us find anything that we don't know yet. So we can write a similarity statement. Instead of writing the words triangle ABC is similar to triangle DEF, you can use a symbol, as always. And you just use the little squiggly. It's the top of a congruent symbol, okay? Because congruent, remember, means same size and shape. Similar only means same shape. So you've got the part of it. Equal means same size. Similar means same shape. You put them together, you get congruence. So just add this. Your pre-image is similar to your image. Pause here just a second. Any questions? So now what we can do is solve some problems. Okay, I've got two similar triangles here, RST and XYZ, and I'm going to label, first of all, I'm going to list the pairs of angles that are congruent. So let's see, R corresponds to X. S corresponds to Y, and T corresponds to Z. Next, I'm going to write the ratio of the side lengths. So a statement of proportionality is like this. A proportion is a fraction equal to a fraction. So as long as you have something like this, then that's called a statement of proportionality. So again, I could do this in, I could do it in colors. Okay, I can write that ZY, TS, I can do XY, RS, and ZXTR. So that's called a statement of proportionality. Now if I actually want to solve for something, which means the scale factor, I can take any of these ratios and I can plug the numbers in and I will get the ratio from part B. So you know what I'm going to do? I'm just going to pick the smallest numbers because I always like to make it easier on myself. So I'll do the blue ones. Okay, so I'll write this ratio. It's 12 over 20. And they'll all give you the same, so it doesn't matter which one you do. And I know 4 goes into that, both of them, so I'll reduce that by 4, and that's equal to 3/5. And clearly, this one's smaller than that one, so that makes sense that this number is less than 1. From bigger to smaller by 3/5. So this is again where I pause for a second and I ask if you have any questions. Okay, we're going to do an example where there are unknown sides. So this is all just practice and hopefully review. Hopefully it looks a little familiar from before. But now we're going to solve some problems. So here's what it says. If two polygons are similar, then the ratio of any two lengths is equal to the scale factor. Okay, so K is equal to any of those fractions that we just wrote. So here's an example. It's telling me that this is similar to this one. So I want to find X, right? That means I can write any of these ratios where the one over the other equals x over something. So if I'm going from here to here, remember this is my image, this is my pre-image. So clearly I'm going to want to do x. So I want to do 30. So what I'm going to write is 30 over x equals. So this is my image, this is my pre-image. That means I can either write 24 over 20, because that would be the bottoms, or I could write 18 over 15. You can write either ratio. Now to me these numbers seem easier, so I'm just going to pick 18 and 15. But that's all the work that is involved. You set up the ratio and boom, you get x. So I can either cross multiply 30 times 15 equals 18 times x, or another thing you could do is you could figure out how many times 18 goes into 30 and then multiply times 15 to get x. But a third way I could do it is I could just reduce these numbers because I see that they have common factors. So I'm going to reduce this by 3. Just to make them smaller. That's the only purpose, because I hate pulling out my calculator. And now I can see that 6 times 5 is equal to 30, so 5 times 5 will equal x. Of course, if you want to do it a little more formally, you can do cross products. So this would be 6x equals 150, and then I would end up using my calculator. I get x equals 25, and I promise you that if you did, instead of 18 over 15, if you did 24 over 20, you'd still get 25. That's the beauty of it. Okay, so again, if you have a question, raise your hand or unmute yourself. So now we're going to look at this one. It says that this small triangle is similar to this big triangle. Find the length of the altitude PS. So here's PS. I'm going to mark it with I'll call it A for altitude because I already have an X over here. So I got to figure out what A is. If you had these, faced up, the corresponding sides, A is corresponding to 20. So I'm going to be able to write, and this I'm going to do 20 over A because this is my image and this is my pre-image. So 20 over A will equal, well, I could either do 16 over 12, or because the parts, that's what our symbol says, the parts correspond, I can just do 8 over 6. The big over the little equals the big over the little. Again, I'm just keeping the numbers small. And I'm going to reduce these before I do any other reduction because from here I can see that 4 times 5 is 20, so 3 times 5 will give me A equals 15. But again, if you want to do the cross multiplication or the cross product because you don't 100% know what it is, then you get 4 times A equals 60, and you divide both sides to get A equals 50. Or equals PS, because that's what we were looking for. All right. Give you a chance to turn over to that other picture, because this concept, or these concepts, have a little bit more to it, and when you did this in Math 8, or whatever class you did it in before, when you did transformations, there was also a theorem or theorems involved in perimeter and area, because this scale factor can be used for that too. So perimeter and area, okay, can be solved using scale factor, which means now we're on page 20 in your book. It's the next page. It's still 8.1. I just broke it up so that you'd have that separate idea. So my goal for you at the end of these next 10 minutes is that students will be able to find perimeter and area of similar polygons using only their scale factors. In a way, it's a little bit like a shortcut. So here we go. Hopefully this will sound familiar. Perimeters of similar polygons theorem says if they're similar, then the ratio of their perimeters is equal to the ratios of their corresponding side lengths. So I'm going to write this out. The scale factor is equal to the perimeter ratio. We're going to use that to solve some other problems. So if I was going to look at this, then say for instance I just look at this side here, Kn and Ps. They're both in the same direction, so I know that those are corresponding parts. So I can write this equation, Kn over Ps equals, well actually I want to do it the other way around. I want to do the image on top. Ps over Kn, it doesn't really matter. But it's the perimeter of PQRS over the perimeter of KLMN. And so this is a proportion you can write. A fraction equals a fraction. If you have three of these numbers, you can figure out the other one. So we actually have that example right here. The two gazebos shown are similar pentagons. Find the perimeter of gazebo A. Now look, you don't know what these other parts are here. You don't even know what this is. All you know is this one side here and that they're similar. So what you can do, again, is you're going to use this. The scale factor is going to be 10 over 15 or 15 over 10. It doesn't matter which way you do it as long as you're consistent. So the scale factor will be 10 over 15. We'll do it that way. Okay. You want to find the perimeter of gazebo A, and that goes along with 10, so that goes here. So perimeter A, I'm just going to put that there. And then down here, add up all these numbers, and that goes there. Then you have a fraction. So let's see, 18 and 12 makes 30. 15 and 15 makes another 30, so that's 60, and I have 9, so this will be 69. Again, I don't know what the numbers are here, but I do know I can reduce these. You don't have to, but I'm going to simply because I like smaller numbers. And again, I can do these in my head if I don't, but you can go straight to the calculator with that if you want. But I do know I can do 2 times 69 in my head because it's 2 times 70 minus 2, which is 140 minus 2. And so then I get 3 times, I'll just put an A there. And I will grab my calculator for this. 3 goes into 138, 46 times. So isn't that nice? It's just a fraction and a little division. I don't have to know all these other sides. I can figure out the perimeter. We're going to do another one that's very similar, only now we have rectangles. So I'm going to draw a little rectangle. I've got rectangle ABCD. It has a width of 8 and a length of 20. Those are yards. It's telling me that it's similar to WXYZ, so I'll make that a little bit bigger. WXYZ, they have to be in the same location. So A has to correspond to W, D has to correspond to Z, same thing. Okay, so it's just asking me what the width is. So here's my width right here. What do you think the width is? Some of you can probably even tell by looking at it. If you can't, we can always write that ratio. So it's going to be 20 over 40 equals 8 over whatever we want to call that. Call it something else. Let's call it question mark because I already have an X and I have an A and okay. So 20 over 40, 20 over 40 equals 8 over question mark. It is 16. How do you know?
Because 20 over 40 is 1/2.
Yeah. Because this is 1/2, which means 1 times 8 is 8. So anyway, there's a number of different ways to solve that. It's just nice to have a theorem that gives that. You could almost eyeball it here. I know some of you can. You're just being shy. Okay, so we're going to do another example just like that, where I'm giving you a perimeter, and now you have to find the side. No, I think it's the other way around. I give you the sides, and you have to find the perimeter. Same thing. So figure A has perimeter 42, side length of 15. Figure B has a corresponding side length of 35. What is the other perimeter? Let's just do triangles. I'm going to say figure A and figure B. Those are not the same size. Just mark them that way. This one has a side of 15 that corresponds to 35. Doesn't matter where you put them, as long as they're in the same location. This one has a perimeter of 42. And it's saying, what is the perimeter of figure B? So again, our little formula here is scale factor equals the perimeter ratio. Just want to remind you because you can't see it. So the scale factor is going to be 15 over 35. And the perimeter ratio will be the A perimeter over the B perimeter. Bunch of different ways to solve that. Again, I'm going to try to reduce this just to see what happens. I know 5 will go into both of those. So now I have 3 over 7 equals 42 over P. And because I know numbers really well, I know 3 goes into 42 14 times. And so 7 times 14 gives me 98. Those are feet. But if you want to do it long ways, you could do 7 times 42 equals 3p, and you will get the same answer. So any questions? All right, again, unmute yourself or raise your hand if you need to. We're going to do now, does that make sense where the ratio of the sides equals the ratio of the perimeter? Because all you're doing is add them up. And if I could see your faces, I would probably see you shake your head up and down. I'm also wondering, does this look familiar? Right, what we've done before. Okay. So area is only slightly different. Same thing, except the difference here is now instead of scale factor of like K, now you're going to multiply sides because area is squared. So it'll be scale factor squared. So on the back, it's almost exactly the same, right? If two polygons are similar, then the ratio of their areas, so ratio of the areas is equal to the squares of their ratios. It's very similar. I'm going to go ahead and write it down like this. So instead of just scale factor, it's going to be scale factor squared. Very similar. Okay, let's say I have, I'll just focus on these sides to do the scale factor. Then I have NM over SR. That's going to give me K. That'll give me the scale factor. But what I'm going to do is square it, and it's going to be equal to the area of KLMN over the area of PQRS. And I know everybody here knows how area works, so I'll just go ahead and jump right into an example. We've got this one similar to that one. Find the area of DEF. Okay, so we're looking for this area over here. These two sides will give me K. So that'll give me my scale factor. So we'll do 10 over 5. We're going to square it. It's going to equal the area of this one, which is 36, over the area of this one, which I don't know. As simple as that. You just have to remember to square. So there's a number of ways to do this. You could square all these numbers. You could notice that 5 goes into 10 twice. So, 5 goes into 10 twice, then 2 squared is 4. So what number that goes into 36 equals 4? Well, you could solve that. A is 9. And those, of course, are centimeters squared, same units. Questions? Almost as simple, just got to remember that square. Area is squared. Okay, figure A has an area of 72 centimeters squared and a side length of 6. Figure B has a corresponding length of 5. What's the area? So I'm just going to make triangles because they're the shortest things, they're the easiest things to draw. I know that this has an area of 72 centimeters squared. I am looking for this area. It says this one has a side length of 6 centimeters, and this one has a side length of 5 centimeters. They're all centimeters, so I don't have to worry about that. But again, scale factor squared equals area ratio squared. So 6 over 5 squared, 6 over 5 squared, equals 72 over area. Okay, just so you know, if you wanted to, you could write 5 over 6 squared equals A over 72. You'll still get the same answer as long as it is at the right place. So this will give me 36 over 25 equals 72 over A. Did anybody notice now that 72 is twice as much as 36? So you can either cross product and get 36A equals 1800, or you could just go straight up here and notice that the area equals 50, and those will be centimeters squared. 36 times 2 is 72, so 25 times 2 is 50, so that's a reasonable answer. Plus, this area is smaller, and that makes sense, because this side's bigger, bigger area, this side's smaller, smaller area. Always just do that double check there, right, to make sure that your answer doesn't sound crazy. And we're almost done here. Number 6, figure A has an area of 24. It just says figures, so I'm going to do another figure A and B. Okay. It has an area of 24 units squared, and B has an area of 216 units squared. If figure A has a side length of 6, what is the corresponding side length of B? So I'm going to call this X. It's only slightly different because, again, you're using areas, so you have to square them. So let's just do 6 over X, 6 over X, scale factor squared equals 24 over 216. The 6 goes on top, then the 24 has to go on top. X goes on the bottom, then 216. This could be written upside down, but you're going to have to do a little bit of math here, because this will give you 36 over x squared. Now at this point I could like reduce stuff, but the numbers are bigger than I care to notice, so really what I could do is just, let's do cross products. Grab our handy dandy calculator and do it the hard way. Should I call it the hard way? Where I do 36 times 216, and then I'm going to divide by 24. And so I get answer of 324. That doesn't sound right. Oh, I know, because that's x squared. Okay. So 36 times 216 gives me, oh wait, so this is 324 equals x squared. Goes from here to here. And then when I square, clear. When I square root 324, then I get 18. That sounds reasonable. I knew that other number was too big. So x equals 18 units. All right. That is reasonable. This is 3 times bigger. Okay, so 6 and 18. I'll bet you anything that 216 is 9 times bigger than that. I'm just going to check. So 24 times 9. Whoop, I was right. 216. So because it's 3 times 3. So if this is 3 times bigger, then this is 3 squared times bigger. Whoop. Okay. I didn't notice that last time I was doing the notes. All right, and last but not least, if you get a couple of things to compare, all the ratios of the sides are equal, but the polygons aren't similar, then the thing is, your angles, you have to check all your angles. So see how this angle and this angle are not the same? This angle and this angle is not the same. You can tell they're not the same. So not all corresponding angles are the same. I'll say are congruent. So these polygons are not similar. So if you get a picture, all you have to do is compare them and say that they're not, or they are. You have to just check all of them.